This is a calorimetry problem. We recognize it because there are two things that are changing temperature. We see that there's a sample of metal that starts at a high temperature and is cooled down, and we have water that is going to increase in temperature. And here we're given our final temperature of both. Let's give ourselves a diagram to organize what's going on. We have a metal that starts at 101.0 degrees C, and we have a temperature bath of water that starts at 21.0 degrees C. And both of them are changing temperature. The water is heating up. The metal is losing heat, cooling down. There are two different temperature changes. For the metal, the delta T is the final temperature minus the initial temperature of the metal, and that is equal to a minus 76.7 degrees C. For the water bath, we have delta T is the final temperature minus the initial temperature of the water bath. So that's going to be a positive 3.3 degrees C. So two different things are changing temperature. That tells us this is a calorimetry problem. We'll start with the first law. And that tells us that the heat gained plus the heat lost has to sum to 0. We can remind ourselves that the water bath is gaining heat because it's increasing in temperature, and that piece of metal is what's losing heat, it's decreasing in temperature. So each of these are changing temperature. So we apply an equation that the heat is going to be equal to the mass times the specific heat capacity of that item times the delta T of that item. For the cool water, the temperature, or the mass, is 100 grams. Our heat capacity is 1.000 calories per gram degree C. We could use either the specific heat in terms of joules or calories. I'm going to use calories because the numbers are just nicer. And the delta T, as we've determined below, is a positive 3.3 degrees C. The metal has a mass of 40.0 grams. Its specific heat capacity is what we're trying to calculate, so we'll leave that as C, and its delta T, as we've seen below, is negative 76.7 degrees C, and these sum to 0. All right, so let's just do the math associated, and this becomes 330, and to that we're going to add the product of 40 times C times minus 76.7, and that comes out to be a negative 3068 multiplied by C, and all of this sums to 0. Remember, we're solving for the unknown variable, which in this case is C. The result is that we have 3068 times C is going to be equal to 330. We solve for C as 330 divided by 3068, and our calculator answer is 0.10756. We can use 2 sig figs to justify our answer, so our final answer is 0.11. We're working with calories, so this is calories per gram degree C.